I'm so tired.
Yeah. So yeah. All right. You guys have any questions about lesson 9?
I couldn't complete the group meeting quiz before this meeting.
What did you say?
I couldn't complete the quiz.
Oh, like the preparation quiz?
Yeah, this group meeting quiz before this meeting.
Oh, that's okay. That's what we're here for.
Yep. I don't think we have to.
Okay.
Unless I'm mistaken. We were supposed to be doing that the whole time.
Yeah, I think we're supposed to do it on the call.
Yeah. All right. Well, let's do it then together.
Let's do it. I'll be honest. I read through the homework a little quickly, but it seemed to all make sense. So I'm sorry if that understood itself. But
No worries. We'll be fine.
all right, let's do this.
Okay. You guys ready for question 3?
Yes.
Yes.
All right. Which hypothesis involves equality? The null hypothesis.
HO.
Does everyone agree?
Yes, sir.
All right. You got number 4, Meryl.
I do. Sweet.
Yep.
All right. P-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Remember, okay, that's the same statement. When computing the p-value, which hypothesis do you assume to be true? The null hypothesis, right?
Yep.
Right.
There we are. Chris, you want to get that question?
Yes. Suppose the null hypothesis is H of 0, mu equals 10. Use this information to answer the next 3 questions. Question 5. Which of the following represents the alternative hypothesis for a two-tailed test? I think is
It's the not equal to, right?
Yep.
not equal. Yes, is the third option. Yes.
Yeah.
Yeah. I agree. All right. And then
My turn. Which of the following represents the alternative hypothesis for a left-tailed test? H is less than 10.
It's less than, right?
Yep, I think so.
All right. And which represents the right tail test? I'm going to say greater than.
You got it.
If it were up to me.
You got those,
First
Chris?
You said first. First option.
7 was the greater than symbol, according to Meryl. Math according to Meryl.
You should start a YouTube channel, Math According to Meryl.
Math according to Meryl. Everyone's going to attend that class. Are you current, Chris?
Question 8.
Yeah, are you good?
Remember that we determine the outcome of hypothesis test by comparing the p-value to the level of significance, or alpha. Question 8. Which relationship will result in failing to reject the null hypothesis? I think is p-value minus, how do you say this symbol? Second? The second option?
The less than. Is that what it's called? What's it called, Brent? Do you know?
less than,
what?
greater than symbol. I don't know. That's what I've.
They have like, yeah, that's what I always call them, but I don't know if they have like a technical term. I don't know.
Okay, I think it's the second option. The second option. Yes.
Reject the null hypothesis. The opposite.
Yeah, I think it's the greater than, right?
Greater than?
Is that right? Or
I think it's greater than, but I
Filing to reject.
I'll look it up real quick.
Filing to reject. Okay, I think I understand now.
can you guys hold on 1 second? Sorry.
No problem. So if the p-value is less than or equal to alpha, then you reject it. So yeah, so if it's greater than alpha, then you fail to reject it. If it's less than, then you reject it.
Yes.
Which is the next question.
Sorry. Did we move on or did we?
So I looked it up, and if the null or if the p-value is greater than alpha, then you fail to reject it. If it's less than, then you can reject it.
That's what I thought. Okay. So that's question 8 and 9, right?
Yeah.
Yes.
Okay.
All right, I'll read question 10. An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. Use this information for the next 2 questions. Which of the following would be the appropriate alternative hypothesis?
Claim amount is greater than 1,500.
Yep.
All right. Which would be the appropriate null hypothesis? The average claim amount is equal to 1,500, right?
Got it.
I like this week's homework. This is good.
Nice and easy so far. Just wait till we have to calculate stuff.
Yes.
All right.
All right, Chris.
You got 12? Or Chris, whatever.
Pardon me. I'll read it.
Question 11.
Sorry?
I missed question 11 because I was reading.
So the null hypothesis. So the null hypothesis is always equal to what you previously thought the mean was. Yeah.
So the null hypothesis just means no change. So if they currently thought that the mean was 1,500, the null hypothesis would just say that doesn't change.
Okay. The insurance company random selects 40 claims and calculates a sample mean of 1,650. The insurance company assumes the distribution of sample means is normal. Is this a good assumption? It's a good assumption since the sample size is large.
If I think so.
I think so. Yeah, I'm gonna go with that.
All right. So question 13. What theorem or law justifies your answer to the previous question?
Okay.
Law of large numbers?
Central limit theorem.
Yeah,
Which one?
I think it's the law of large numbers, right?
I don't know. I always get these two mixed up.
Actually, it might be the central limit theorem because central limit theorem just basically says that the sample mean will be normal if the sample size is large. So I think this is the central limit theorem, if I were to guess. But I could be wrong.
Yep, I think that's right because I think, yep.
They're similar in nature.
I think you guys are right.
Okay. All right. Question 14. Which of the following is the test statistic as defined this lesson? Would be
X bar. I don't know actually, but I would just imagine.
I think it's second option.
Really?
Yes, because the textbook says that you calculate the statistic with the C-score.
Okay.
I think so.
okay.
Sounds good to me.
Let me just make peace with that really quick. Okay, I'm down with that. Are you down with that, Brent?
Yep.
All right, Z it is. The historical mean of sales receipts at a grocery store is 150 with a standard deviation of 40. The store manager suspects that the average has decreased. She sets up a hypothesis test with the hypotheses of the alternative that it's greater than 150. She will use a level of significance of alpha equals 0.05. She then takes a simple random sample of 36 receipts from her store and computes a mean of 144. So what is the z-score associated with this test? Okay. Here comes my faves. So since the standard deviation is 40, So it's 0.15, is that right? Or am I wrong there?
Let's see.
Because the z-score is just how many standard deviations it is away, right?
Yeah. Did you get negative 0.15?
Yeah.
Sounds good to me. I don't remember if they showed us a new formula, I think. What was significance? I think, yeah, you're right.
Because
What is a
dollar
p-value?
is,
That was the, yeah, I think it's right. I think I'm thinking of the p-value.
okay. What do you think, Chris?
I don't know how to do that.
So from my understanding, you just calculate the z-score by calculating how many standard deviation your sample mean is away from your population mean.
Okay.
So the standard deviation is 40. So I took 40 and divided it. I'm sorry, I took 6, which is $6 under the population mean, and I divided it by 40. So $6 is 15% of 40, which might be a little roundabout. But so the answer I got was negative 0.15.
Yeah, you'd want your 6 to be a negative 6 in your calculation.
Yes, sorry, I didn't make that clear.
Let's see if I can find this. How to calculate p-value.
P-value, wouldn't that be 0.88? 0.881 or something?
I honestly don't know. I'm trying to find the p-value calculation. Let's see. So what did you use for your calculation?
I used the little tool. I'm trying to get back there now. I went in search of the curriculum for it.
The applet thing?
Yeah, because it says what is this? So we take the z-score, right, and you use that little curvy guy.
Alpha.
But
So z-score, and then what do you do with the curvy guy? Do you know?
so it says if it is, let's see, for a left-tailed test, which is this left-tailed? We're
Trying to see if
yeah. So for a left-tailed test, the p-value is the area under the standard normal curve to the left of the test statistic. So,
which is the standard deviation, which is the z-value or z-score. I mean,
let's see. Score, yes. If x is close to the mean, the z-score will be small. Yada yada. And the p-value will be large. So is the p-value what's not included in the z-score? Is that what we're saying here?
let's see. So what did the applet tell you it was?
I am not sure of myself, but I thought it was like 0.88. Because if you put, I don't know.
Let's see here.
They don't cover this very well. I read it over several times and I'm still confused on it. It sort of made sense when I read it at first, but
Let's see. So let's see. 0.88. Two-tailed p-value. So
is there a link to the applet in this lesson?
I don't know.
Trying to get back to it. I think you just plug in the z-score.
So I looked up a another calculator online. Love it. I mean, this cannot be that hard to compute. I don't know why I can't find it.
I'm sure it's like simple. It's just not explained very well.
So it gave me 0.88 as well, but that was a two-tailed p value.
Oh, when it's not two-tailed.
And it's not two-tailed.
It's left winged. Okay. This cannot be that hard. So I just need to find my applet again, wherever the heck that is.
She scored a p-value calculator. Oh, come on.
Where did I get that applet?
I have no idea.
I'm like going back through all the lessons and I can't find it, but I know I clicked on it and had it.
Yeah. Oh my Atlanta. Why?
Okay. Lesson 5. So I'm going to plug our z-score into this dude. Negative 1.15. Okay, fine.
So I think I know what it is. Possibly.
What do you think?
Let me try something real quick.
Is it just the number that it gives you at the top?
All right. I think I know what it is. The p-value. So the reason we're getting 0.8808 for a two-sided tell is basically because the percentage on the left side of the z-score of negative 0.15 is 44%.
Mm.
And so on the right side of a z-score of 0.15 is 44% as well. That's 0.88. And so just the left side would be 0.44, I think.
Well, that makes sense because I'll tell you what. I just plugged the z-score into the probability applet, which turns out is a tool that just does this for us. And the number at the top is 44%. So,
oh my goodness. We got it.
there we are. It's, yeah. Yep. Okay, great.
I don't even know why we learn statistics if there's just
Like, here's a tool. Use that.
I'm just kidding. That's nice of them.
Yeah.
So 0.44.
0.44.
0. On 3 decimal places. Do you put a 0 at the end if it wants 3, but it's a 0?
I did, but I don't know if that's good form. I don't know if it cares. It did say 3. Okay, so it says that if the z-score is small, the p-value will be large. And
Makes sense.
So if the p-value is less than alpha, we reject the null hypothesis. If the p-value is greater than alpha, then we fail to reject the null hypothesis.
That's correct.
Alpha, 0.05. It is
our,
greater than alpha.
got it.
So we fail to reject the null hypothesis, right?
Right. Yep.
Right. All right. You with us, Chris?
Yes, but I don't know what you are doing because I don't know how to solve this question.
This
You don't know?
17 or the one before?
16.
Yeah, 16.
So all you have to do is get the applet, and it tells you what the answer is.
So it's that like curve that goes like this?
Yes, but the area could be like 0.05.
Almost. So did you plug in the negative z-score at the bottom?
Yes.
So, and then the area should say 0.044 or something? 0.44 is 04. Is that what it says?
So make sure you type in the z-score, not the alpha.
One tail, left tail, yes?
That's right.
This is core.
So what do you have typed into the bottom of the applet?
No, I can't.
So what are you typing in at the bottom for the z-score?
Negative 0.15.
Yep.
And
Then
the
just
area?
then you just have to click on the left side of it, right? And it'll pull it up.
Yes. But the area is 0.4404.
That's it.
Perfect. That's it.
So that's the
And
p-value.
The p-value.
Yeah.
Okay, I got it.
Okay. So
All right.
question 17, we decided was fail to reject the null hypothesis because the p-value is greater than the significance value, than alpha. And then question 18, our conclusion for the problem. Do we have insufficient or sufficient evidence that the true population mean is 150, or insufficient or sufficient evidence that the true population mean is less than 150. I think we have insufficient evidence that the true population mean is less than 150.
You got it, I think.
It's my...
Sorry. We failed to reject the null hypothesis in question 7.
Yeah, question 17 was we're failing to reject the null hypothesis because for all we know it could be correct.
Yes, I'm trying to understand why, but yes.
So basically, our data didn't give us a high enough significance value. It wasn't significant enough, so we're just staying where we're at.
Yes, thank you.
No problem. Question 18, I think, is the third answer. Because we did have to reject the null hypothesis.
Of course, yes.
Okay.
Thank you.
Yeah, no problem. All right, you want to get question 19, Chris?
There are 2 types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? Type 1?
It involves rejecting the null hypothesis. I think you're probably right. Null hypothesis true. So type 1 is when the null hypothesis is true and you reject it. Yeah.
Okay, perfect. All right, your turn, Brent.
A researcher decided that instead of using a level of significance of 0.05, he will use a 0.01. Which of the following will be true?
Type 2 error?
So which is the following? So type 1 is rejecting the null hypothesis.
Or maybe it's type 1. Because it would make your probability level wouldn't have to be too high in order to reject the new hypothesis.
Let's see. Type 1 error will increase, I think is, let's see. Because if your p-value is higher, then you fail to reject it, right?
Yes, or no, so the
Opposite.
I think it's the opposite. I'll get back there.
Failing. P-value is greater. Yeah, so if the p-value is greater, then you fail to reject it. So we're making it harder to fail to reject. So
Harder to fail to reject. So that's a type 1 increase.
Rejecting the null hypothesis. Oh my gosh, I'm like, it's too late at night. Involves rejecting a null hypothesis.
If the p-value is greater than A, then we fail to reject. If it is less than A, then we reject. So if we're decreasing A, then it makes it easier for the p-value to be greater than A and easier to fail to reject the null hypothesis. So that would be a type 2, right? Because type 1 has to be rejecting it even though it's true. Or no, maybe it's type 2 because we make it harder to fail to reject. Right? Is this making sense to you? I'm walking myself in circles at the moment.
So we're making it harder. So we're making it harder to reject when it's true. So the probability of type 2 error will increase.
Type 2 it is. Okay. If alpha equals 0.05, compute the probability of committing a type 1 error.
I bet.
I don't know how I would go about computing that.
I am just going to compute this with using a type 1 error is rejecting. That's true. P-value is greater than you failed to reject it. P-value is greater. So it's 0.05. Then to make it fail. I'm gonna just do a logical, what I think is logical, and submit it, and then I'll let you know. All right, I got it.
Okay, what is it?
It's 0.05.
So why?
Okay, so a type 1 error would only happen if the p-value was less than 0.05, right?
Mm-hmm.
And so the probability of the p-value landing over there is 0.05% or less.
Okay, I'm there. I got it.
But crap, we got some wrong.
What did we get wrong?
Knew it was wrong. Okay. So there's something you got to do. So question number 15 and 16 are wrong.
That one.
I think
So we
when
got
you
the
find,
score wrong. That must be it.
hold on here. So the z-score was wrong.
Okay.
So I think we have to use the alpha in the z-score somehow.
How does that relate to the how does that relate to the alpha?
I have no idea.
Oh.
I feel like that's the z-score though. Like, that's the only thing that makes sense. Because what else would it be?
Here. I swear, if I just knew the answer, I could figure it out. My brain works backwards sometimes, I think.
Good skill to have. I just plugged it into like a calculator, and it says the z-score is negative 0.15.
But I think it might be different when you have a level of significance.
Okay. Let's see if it's anything.
Score calculating recommended numbers. I have no idea. I don't know, but we did get a 91% anyways.
It has to be z-score because the other thing did it for us based on z-score. But I don't see anything in this lesson that's teaching me that the z-score calculation alters according to alpha.
Well, let's take a look here.
Do you think it's because we did it negative? No, it would be the same.
I mean, it is supposed to be negative.
I know, but there is the whole issue with the negative numbers. But that doesn't make any sense either. It would be positive.
Oh, I did only put 2 decimal places.
I put 3. Oh, do you think that's it?
Let's see. What's the... but it's just zeros. Oh, wait. Hold on.
I can try. I can sacrifice mine because you already did. I'll do mine.
Yeah, it is just zeros. I don't know. But I got 16 wrong too, so the z-score would have to be wrong. Or we just don't know how to calculate the p-value, but I think we do.
The z-score has to be wrong. Yeah, mine's wrong. I don't know how the z-score is wrong because it doesn't make sense, and I don't see it. I don't see anything here that says to calculate using the alpha in any way. Do you recall anything?
It's in the video that I watched. Let's see, it talked about something. See if I can find it anywhere. Hold on. I think I found it. State the null and I determine the letter of significance. Mostly given to you in this class. Significance. 0.1 be the test statistic.
We talked about that in the last video. Step number 2 is try to compute the test statistic. Here's the test statistic, it's the z-score. I referred to this earlier with the p-value here, where we say the probability of obtaining a sample before test statistic is this is extreme as the one you calculated, assume that no one's true. So the step 2 over here is the test statistic, it's the z-score. You've seen this formula or something similar to that before back in unit 1. Then step 3 is get the p-value. So we'll use the alpha to get the p-value. And then step 4 and step 5 is what you're going to be seeing throughout the semester. Step 4 is that we would all ignore this the decision rule because we don't have that as a definition. But we reject the null hypothesis if the p-value is less than the level significance. If not, then we don't reject. And then we state our.
So confused. I think can't see that. Square root of n. Do we know how many? Let's see. I have no idea. Here. I'm going to share my screen real quick. That's right. Trying to figure out how to zoom in, but I can't. But this little
Conclusions.
equation right there, do you see it?
Yes.
Is the z-score.
Yes.
And it's a little weird. It's got the mean minus or x bar minus mu and then something else, but I can't tell what that is. Over the standard deviation, but divided by the square root of n.
Okay.
I don't know.
I don't know.
We don't have an n. That's not given to us. The number of
Well, what does N stand for?
it's like the number of samples or the number of people take population or not the population, the sample size.
So 36 sales receipts. That would be it, right? 36.
Where does it say that?
She'll use a significance level of alpha equals 0.05 and then take a simple random sample of 36 sales receipts from her store. Computes a mean of 144.
There it is.
Well, there it is. So this fancy little guy.
Right. So I'm not even going to go back and fix my answers because I'm too lazy right now. But I think I know what they are.
So what's the z-score?
Negative 0.9.
0.9. Okay.
Did you get that?
I know.
Just divide the normal z-score by the square root of 36.
Negative 0.9.
Negative 0.9. Okay. Cool. And then the applet then, negative 0.9. Gives me an area of 0.184.
Yep.
Okay. I am going to fix my answers.
Let's see if it works. Ugh. I hope it does. Then we know how to do everything.
All right. Let me go in there. 14153.
I guess I can stop sharing my screen.
Okay.
Did you guys submit it?
Not yet. Sorry, I'm fixing all my. I have to redo all my answers.
I think it was just the only ones we missed were 15 and 16, but
Right, but I still have to answer them all, right?
oh, did you submit it once already?
Yeah, I did.
Oh,
To see if the 3 decimals was going to work out. 184. Okay, but I'm almost done. 1792, 1803, 1911, 20. Okay, let's try. Let's try it. %.
ah, good job.
All right,
All right, good job.
works.
All right, well, thanks, guys. Any questions before I leave?
No, sir. Will you just post the video?
I will do that.
Sorry, guys. I don't know how what was the answer for these questions.
For which one? The 16?
Yeah, both 15 and 16.
16. So we had calculated that this z-score is -0.9.
Yes.
So that's 15. That's the answer to 15. And then if you plug in the 0.9, the -0.9 to the applet tool with the curve, it'll give you an area of 0.1841.
Yes.
So, and then that's the answer to 16.
Really?
Yep. Simple as that, man. Not that simple. It took us a long time.
It's like in previous lessons, yes?
Yeah.
The same process.
I guess they're just calling it different things.
Good way to
It's
look
just-
at it.
Yeah, it's just kind of looking at it when you're trying to prove something wrong,
Yeah.
but you're doing the
Okay.
same stuff.
Does that make sense?
Yes. Yes, thank you.
Cool. All right,
All
guys.
right.
We'll,
Okay, take it
see you on
easy.
Tuesday.
Sounds good. Bye.
Bye.